exists for digits in the ones place for the value that results from raising 7 to the power of n, where n is an integer greater than or equal to 0. If you look at the given information, the pattern is 7931. Then it starts over again, 793. Using your calculator, you can verify the last part of this pattern, raise 7 to the 8th power, and the digit in the ones place will be a 1. So our pattern is definitely 7931. The question says, which digit is in the ones place of the value of 7 to the 50th? So the exponent is 50. So we have to use these exponents over here along with our pattern. Notice from 1, 2, 3, 4 creates one pattern. 5, 6, 7, 8 creates another pattern. So every fourth exponent creates a whole new pattern. So we have to go all the way up to 50. So we have to look for the biggest number less than 50 that is divisible by 4. The biggest number less than 50 that is divisible by 4 is 48. So if we raise 7 to the 48th power, that would end our pattern. So that means 7 to the 49th starts the pattern. That means 7 to the 50th would be second in the pattern. So if the pattern is 7, 9, 3, 1, 7 to the 50th would have a ones digit with a 9 in it. So our answer for number 1 is B, 9. Number 2, simplify. We have to take care of exponents. We have to be careful about negative exponents. We have to be very careful that we realize that this negative 2 and 5 are not exponents, but they are coefficients. This 5 is outside these parentheses, so we have to raise everything inside the parentheses to the power of 5. So that's negative 2 to the 5th, which is negative 32. X to the negative 5th to the 5th, exponent to exponent you multiply, so that gives us x to the negative 25th. Y cubed to the 5th, exponent to exponent multiply, get y to the 15th. No sign in between these parentheses, so we have to multiply. So now the 5, the x squared, and the y to the 7th is all squared. So 5 squared is 25. X squared squared, exponent to exponent multiply. Y to the 7th squared, exponent to exponent multiply. Now we multiply negative 32 times 25, we get negative 800. We multiply x to the negative 25th times x to the 4th. That gives us x to the negative 21st. When the bases are the same and you're multiplying, you add the exponents. Negative 25 plus 4 is negative 21. Now we have y to the 15th times y to the 14th, which gives us y to the 29th. Again, bases are the same, you multiply, so you add the exponents. So it's y to the 29th. We don't want negative exponents in our answer, so there's nothing wrong with negative 800. There's nothing wrong with y to the 29th. So the negative 800 and the y to the 29th stay in the exact same place. To make this exponent positive, if x to the negative 21st is in the numerator, we put x to the positive 21st in the denominator. That makes the exponent positive. This answer of negative 800 y to the 29th over x to the 21st is answer choice D. So our answer to problem number 2 is D.